Welcome back to 9th Standard ICSE Mathematics Online Class Session 4.
Hello students, in last class we saw about an interesting topic, simultaneous linear equations, right? Also, I gave you an assignment based on the topic we have seen. I know my students are very good and they would have finished the assignment on time. So, it's time to check the answers.
So the topic which we are going to see today is about indices or exponents. So now let us see what are indices. The index of a number says how many times to use the number in a multiplication. The plural of index is indices. So there are other two names for indices which are exponent or power. So now let us see an example based on this. So here in the given example 2 part 3, 3 is an exponent whereas 2 is a base. So the exponent of a number says how many times the number should be multiplied. So here in this given example 2 part 3, the number 2 should be multiplied 3 times since the exponent value is 3. So the value is 2 into 2 into 2. So that will be equal to 8. So the next is there are 3 types of indices. So the first one is positive indices. Let us see what are the positive indices. So in the first expression 2 part 3, the power of a number 2 is 3 and the power is positive number, right? So it is a positive index. Likewise, in the next example, 10 power 4, the power 4 is a positive index. So this is also an example for positive indices. Likewise, in the next example, x power a, here also the power is a positive number, a is a positive number. So all these are examples for positive indices. So the next one is negative indices. So what are negative indices? So here in the first example 4 power 5, it has a negative power which is minus 5, right? So it is an example for negative indices. Likewise, in the next example y power minus b, here also the power minus b is a negative number. So this is an example for negative index. Likewise, in the next example also 2 power minus 2, the power is a negative number. So this is also an example for negative index. So next is about zero indices. So zero indices will have the power to be 0. So all these are examples for zero indices. And any number to the power 0 will always be 1. So that is a condition. So here a power 0 will also be 1, 2 power 0 will also be 1 and 6 power 0 will also be 1. So this is all about positive, negative and zero indices. Now next is about fractional indices. Now let us see what are fractional indices. If a is any real number and n is a positive integer, then the nth root of a is a real number x such that x power n equals a. So here, according to the definition, they are denoting the nth root of a to be a power 1 by n or nth root of a. So thus, according to the definition, we will get nth root of a equals x. So now if you bring this n to the other side, then it becomes x power n. But here nth root of a can be written as a power 1 by n, since we can denote in both the ways. So nth root of a can be written as 1a by 1 by n. So x as such we are writing. Now if you bring this 1 by n to the other side, it becomes n. Since here it is in the form of division, so when it goes to the next side, it will become multiplication. So x power n equals a. So all these we are familiar with already. So root a can be written as a power 1 by 2. So this we call it as the square root of a. Then this is cube root of a, and it can be written as a power 1 by 3. And this is the fourth root of a. So this can be written as a power 1 by 4. So likewise it goes on up to nth root of a. So now let us see an example based on this. So here the first question is root 9. So root 9 can be written as 9 power 1 by 2. If you don't have anything here, it is understood that it is square root, right? So square root of 9 can be written as 9 power 1 by 2. And this 9 can be written as 3 square. Since 3 into 3 is 9. And the whole square 1 by 2, write as such. Okay. Now if you cancel this 2 and 2, you will get 3 power 1. So 3 power 1 is 3. So that is how we have got 3 here. Likewise, in the second question, we have cube root of 8. So cube root of 8 can be written as 8 to the power 1 by 3. Right. So here 8 can be written as 2 cube. And this whole power 1 by 3, write as such. So now if you cancel this 3 and 3, we will get 2 power 1. Right. So 2 power 1 is 2 only. So that is how we have got 2 here. So here we have seen how to solve fractional indices if the numerator is 1. Suppose you have fractional indices of the form p by q. How will you solve that? Let us see that. So for any rational number p by q, we have a power p by q equals a power 1 by q to the whole power p. That is, they are taking p outside the bracket as whole power. Okay. So now, after which they are interchanging the powers. So p comes inside and 1 by q goes outside the bracket. So that will become a power p to the whole power 1 by q. Now, it is understood that 1 by q is the qth root of this term, a power p. So, we'll get qth root of a power p. So, now let us see an example based on this. So, here we have a fractional index of the form 3 by 2. Here we have numerator as 3 and denominator as 2. So, now according to this definition, we will write 4 power 1 by 2 to the whole power 3. Since here they have given a power 1 by q to the power p. So here for the given question p is 3 and q is 2. So we will get 4 power 1 by 2 to the whole power 3. So next step is interchanging the powers. As they have said here, you need to interchange the powers, right? So here bring 3 inside the bracket and 1 by 2 outside the bracket. So when you interchange the powers, you will get 4 power 3 to the whole power 1 by 2. Now this 4 cube is 64. So that will be the next step. 64 power 1 by 2. Now this 64 can be written as 8 square, right? And the whole power 1 by 2, write as such. So now if you cancel this 2 and 2, you will get 8 power 1, right? So that will be the next step. 8 power 1 is nothing but 8 only. So we have got the answer to be 8. So this is all about fractional indices. So now we are going to see laws of exponents. So all these laws will be useful in solving the expressions. Okay. Now let us see what are the laws. The first law is a power m into a power n equals a power m plus n. And this law is also called as product rule. The second law is a power m divides a power n equals a power m minus n. And they have given condition a should not be equal to 0. Why they have given a should not be equal to 0? Suppose if a is equal to 0, you will get 0 to the power something divide 0 to the power something, right? And that will be equal to 0 power something. So 0 power something will always be 0 only. So they have given condition a should not be equal to 0. So the second law is also known as quotient rule. And the third law is a power m to the power n equals a power mn. So this is power rule. The fourth law is ab the whole power n equals a power n into b power n. Fifth law is ab the whole power n equals a power n divides b power n, provided b should not be equal to 0. And the next law is a to the power minus n equals 1 by a power n, provided a should not be equal to 0. So here if a is equal to 0, the answer will be 1. So they have given condition a should not be equal to 0. In this law, in order to change the negative exponent to the positive exponent, they will reciprocate the base term. So that is what they have done here. In order to change the negative exponent minus n to a positive exponent n, they are reciprocating a term here. Okay. Likewise, the next law is a by b the whole power minus n equals b by a the whole power n. So here also, in order to change the negative exponent to the positive exponent, they are reciprocating this term. So a goes to the denominator and b goes to the numerator. So that is what we have got here. And the next law is a power m equals a power n. So here, if the bases are same, we can equate the exponents. So here the exponents are m and n. So the bases are same here, right? A and a. So we are equating the exponents, that is m equals n. And they have given condition a should be greater than 0 and it should not be equal to 1. Likewise, in the next law, a power m equals b power n. Here the exponents are same. So if the exponents are same, we can equate the bases. So a equals b. And here a and b are positive numbers. So the last law is p power m into q power n into r power s equals p power a into q power b into r power c. So here if the bases are same, we can equate the exponents, wherein which this law has 3 variables p, q and r. So here we are going to equate the exponents. So m equals a, n equals b and s equals c. So that is what they have given here. And here the condition is p, q, r should be different prime numbers. Okay. Now let us see how to use all these laws in example sums. So the first law is a power m into a power n equals a power m plus n. So here the given question is 5 power 7 into 5 power 3. So if you observe the question, it is in the form of a power m into a power n, right? So we can apply this law. So here the a value is 5, m value is 7 and n value is 3. So now we are going to apply the law. So a power m plus n as the law says. So here a is 5 and m is 7. So 7 plus n is 3. So 5 power 7 plus 3. Now if you add the exponents, it becomes 7 plus 3, 10. So the answer is 5 power 10. Okay. The second law is a power m divides a power n equals a power m minus n, provided the condition a should not be equal to 0. So here the example given is 6 power 4 divides 6 power 2. So here a value is 6, m value is 4 and n value is 2. So applying this law we will get a is 6, right, and m is 4. So 4 here. Minus n is minus 2. So 6 power 4 minus 2. So the answer will be 4 minus 2 is 2. So 6 square. Okay. So the next law is a power m to the power n equals a power m n. So here the given example is 11 power 5 to the power 2. So here the a value is 11, m value is 5 and n value is 2. So now applying this law we will get 11 power 5 into 2 since a power m into n. So here a value is 11, m value is 5 and n value is 2. Now if you multiply the exponents you will get 11 power 10. And the next law is ab the whole power n equals a power n into b power n. So the given example here is 24 the whole square 2. So here in the place of a we have 2, in the place of b we have 4 and in the place of n we have 2. So a value is 2, b value is 4 and n value is 2. So now applying this law we will get a power n. So 2 power 2 and b power n is 4 power 2. So 2 power 2 is 4 and 4 power 2 is 16. So if you multiply these two you will get 64. So the next law is a by b the whole power n equals a power n by b power n, provided b should not be equal to 0. So here the given question is 2 by 3 the whole square. So here in the place of a we have 2, in the place of b we have 3 and in the place of a we have, in the place of n we have 2. So substituting the values we will get a to the power n, so 2 to the power 2 and divides b to the power n, so 3 to the power 2. 2 to the power 2 is 4 and 3 to the power 2 is 9. So the next law is a power minus n equals 1 by a power n. So here the given example is 4 power minus 2. So in the place of a we have 4 and in the place of n we have 2. So a value is 4 and n value is 2. So now applying this law we will get 1 by a power n, right? So 1 by a power n is 4 power 2. So that is what we have written here. So 4 power 2 is 16. So 1 by 16. The seventh law is a by b the whole power minus n equals b by a the whole power n. So the given question here is 4 by 2 the whole power minus 2. So here a value is 4, b value is 2 and n value is 2. So now applying the values in the law we will get b by a. So b is 2 and a is 4. So 2 by 4 and the n value is 2. So 2 by 4 the whole square. So next law is a power m equals a power n, then m equals n. So here the given example is 2 cube equals 2 square. So this is similar to a power m equal to a power n, right? We have same basis but different exponents. So here a value is 2, m value is 3 and n value is 2. So now applying it in the law we have to equate the exponents, right? So when you equate the exponents you will write 3 equals 2. So that is what we have written. The next law is a power m equals b power n, then a equals b. Here if you have same exponents we will equate the base. So based on this the example given here is 7 square equals 8 square. So here we have same exponents but different base, right? So applying in the law we will get, so applying the values of a, b and m in the law we have to equate the exponents, right? So here the exponents are 7 and 8. So when you equate the exponents you will get 7 equals 8. So the last law is p power m into q power n into r power s equals p power a into q power b into r power c, then we can equate the exponents, that is m equal to a, n equal to b, and s equal to c. So that is what given here. And here they have given condition p, q, r are different primes. So the example given here is 2 power 1 into 3 power 3 into 7 power 4 equals 2 power 2, 3 power 4 and 7 power 5. So here if you observe this, in the given expression, all the base numbers are prime, right? So now you can equate the exponents. So the first exponent is m equals a. So here m value is 1 and a value is 2. So when you equate, you will get 1 equals 2. Okay. The next is n equals, as the law says, n equals b. So n value is 3 and b value is 4. So when you equate, you will get 3 equals 4. And the next is s equals c. So here s is 4 and c is 5. So when you equate, you will get 4 equals 5. That's it. So we have seen how to solve examples using the laws. Now we are going to see sums using laws of exponents. So the first question is evaluate 9 power 3 by 2. So here we can write 9 as 3 square, right? So that will be our first step. So 9 we are writing it as 3 square, since 3 into 3 is 9. So now if you observe this is in the form of a power m to the power n, right? We have studied one law, a power m to the power n equals a power mn. So applying this law to this term, we will get 3 power 2 into 3 by 2, since m is 2 and n is 3 by 2. Now if you cancel this 2 and this 2, you will get 3 power 3. So 3 power 3 is nothing but 3 into 3 into 3. So that is 27. So next sum is evaluate 9 power 16 to the power minus 1 by 2. So now what we are going to do here is, if you observe this question, it is in the form of a by b to the power minus n. So we have studied one law, a by b to the power minus n equals b by a to the power n. So according to this law, the given term becomes 16 by 9, since b value is 16 and a value is 9. So 16 by 9 and n to the power n value is 1 by 2. So next step is we are writing 16 as 4 square, since 4 into 4 is 16. Likewise, we are writing 9 as 3 square, since 3 into 3 is 9, and to the power 1 by 2 write as such. So now if you observe here, you have 2 common to the power 2 common both the numerator and denominator. So I am going to write commonly outside. So 4 by 3 to the whole power, and this power 1 by 2 write as such. So the next step is, if you observe this is in the form of a power m to the power n, right? So now you need to apply the law a power m to the power n, which is equal to a power mn. So if you apply this law to this term, you will get a to the power m into n, that is 4 by 3 to the power 2 into 1 by 2. So now if you cancel this 2 and 2, you will get 4 by 3 to the power 1. So which is 4 by 3 only. So the next sum is simplify 64 by 125 to the power minus 2 by 3 plus 4 to the power 0 into 9 to the power 5 by 2 into 3 to the power minus 4 minus square root of 25 divides cube root of 64 into 1 by 3 to the power minus 1. So write the given question as such. Now if you observe here, this is in the form of a by b to the power minus n, right? So we can write as b by a to the power n using the law a by b to the power minus n equals b by a to the power n. So using this law, we are writing the first term as 125 by 64 to the power 2 by 3. Now the second term is 4 power 0 As we already studied, anything to the power equals 0 in 0 indices. So here 4 to the power 0 is 1. And here 9 power 5 by 2. So here 9 can be written as 3 square since 3 into 3 is 9. And to the power 5 by 2 write as such. Now here 3 power minus 4. If you observe this, this is in the form of a power to the a power minus n, right? So now we have studied one law, a power minus n equals 1 by a power n. So now if you apply this law to this term, you will get 1 by 3 power 4, since a value is 3 and 4 is n value. Now this term, square root of 25 is 5 and cube root of 64 is 4, since 4 into 4 into 4 is 64. Now 1 by 3 to the power minus 1. If you observe this, this is in the form of a by b to the power minus n. So applying that law here, you will get 3 power 1. So the next step is, we can write 125 as 5 cube, since 5 into 5 into 5 is 125. Likewise, we can write 64 as 4 cube, since 4 into 4 into 4 is 64. And to the power 2 by 3 write as such. Now if you multiply 1 into 3 to the power 5 by 2, you will get 3 to the power 5 by 2. Again, if you observe this 3 to the power 5 by 2, this is in the form of a power m to the power n, right? So now we are going to apply that law here. A power m to the power equals a power mn. So that is how we have got 3 power 2 into 5 by 2 here. And the next term is 1 by 3 power 4. 3 power 4 is 81, since 3 into 3 into 3 into 3 is 81. And here you have to multiply 5 into 3. 3 power 1 is 3 only, right? So 5 into 3 is 15. So that's how we have got 15 here. So minus 15 by 4. So the next step is, here in both the numerator and the denominator, we have to the power 3 common, right? So we are going to write to the power 3 commonly for both the numerator and the denominator. And the whole power 2 by 3 write as such. Now here if you cancel 2 and 2, you will get 3 power 5. And the next two terms write as such. So now if you observe this, this is in the form of a power m to the power n, right? So here if you apply the formula a power m to the power n, you will get a power m into n, that is m is 3 and n is 2 by 3. And 3 power 5 is 243, since 3 into 3 into 3 into 3 into 3 is 243. And the rest two terms write as such. Okay. Now if you observe this term, we can cancel 3 and 3. So the leftover term will be 5 by 4 to the power 2. So that is what I have written in the next step. So 5 by 4 to the power 2. And the rest of the terms I have written as such. Now you can cancel this 81 and 243. 81 1s are is 81 and 81 3s are is 243. So that is how I got 3 here. Now this term minus 15 by 4 write as such. Now here if you observe this, this is in the form of a by b the whole power n. So we can apply that law, a by b the whole power n equals a power n by b power n. So that is how we have got 5 square by 4 square. So now 5 square is 25 and 4 square is 16. Plus 3 into 1 is 3. And minus 15 by 4 we are writing as such. So now what you are going to do here is take LCM. So if you take LCM, you will get 25 plus 48 minus 60 by 16. Right, now if you add these two terms, you will get 73 minus 60 and divide 60. So now 73 minus 60 is 13. So 13 by 16 is the answer. Shall we move on to the next sum? The next sum is simplify 5 power n plus 3 minus 6 into 5 power n plus 1 divides 9 into 5 power n minus 2 power 2 into 5 power n. So let us see the first step. So the given question I have written here. Now here the first term is 5 power n plus 3. So we are going to write the first term as 5 power n plus 1 into 5 power 2. Since we know a power m into a power n equals a power m plus n, right? So in the place of m we have n plus 1 here, and in the place of n we have 2. So that is the reason why we are writing the first term as like this, 5 power n plus 1 into 5 power 2. And the rest two terms in the numerator write as such. Now coming to the denominator, 9 write as such, 5 power n write as such, and 2 power 2 is 4, and we'll be substituting that in the next step. So now here 5 square is 25. So we are going to write 5 square is 25 in the numerator. Likewise, the remaining terms write as such, and in the denominator if you substitute 2 power 2, that is 4. Okay. The next step is, if you observe the first two terms in the numerator, that is this term and this term, you have 5 power n plus 1 common, right? So we need to take 5 power n plus 1 commonly outside. So if you take 5 power n plus 1 commonly outside, here the leftover term will be 25, and here the leftover term will be 6, right? So the next step is, as we saw, if we take 5 power n plus 1 commonly, the leftover term will be 25 here, and here the leftover term will be 6. That is how we have got 25 minus 6. Likewise, in denominator, we have 5 power n common in both sides terms, right? So taking 5 power m commonly outside, here the leftover term will be 9, and here the leftover term will be minus 4. Okay. Now if you solve this, 25 minus 6 is 19, and 9 minus 4 is 5. So that will be the next step. Okay. Now if you observe the denominator, it is in the form of a power m into a power n. Since here m value is n and n value is 1, since you don't have any power here, it is assumed to be 1. Okay. So applying this law, a power m into a power equals a power m plus n, we have got the denominator as 5 power n plus 1. Now we have 5 power n plus 1 in both the numerator and the denominator, so we can cancel that. So the leftover term will be 19. So 19 is the required answer. Understood? Okay, moving to the next sum. Prove that x bar a divides x bar b to the power a square plus ab plus b square into x bar b divides x bar c to the power b square plus bc plus c square into x bar c by x bar a to the power c square plus ca plus a square equals 1. So they've asked us to prove the given expression is true. So what we need to do is, we have to take the LHS term first, and we have to simplify the LHS term. The answer, we should get it as 1. Okay. So to prove LHS is equal to RHS. So now we are going to take the LHS term first. So that is what I've written. I'm taking the LHS term first. Now if you observe here, this is in the form of a power m by a power n, right? So we have studied one law. A power m divides a power n equals a power m minus n. So applying this law, we will get a power m minus n. So here a value is x, and m value is a, and n value is b. So that is how we have got x power a minus b. And to the power term, write as such. Likewise, here also you have to apply a power m by a power n law. Likewise, in the third term also you have to apply a power m by a power n law. So now here again, if you observe this, this is in the form of a power m to the power n. So we have studied that law also. A power m to the power n equals a power mn. So a power m is x a minus b, and n is a square plus ab plus b square. So that is how we have got. So applying this law here, we get x power a minus b into a square plus ab plus b square. Likewise, here also you have to apply a power m to the power n law, and here also a power m to the power n law. So we will get x to the power b minus c into b square plus bc plus c square. Likewise, in third term also, if you apply the law, you will get x to the power c minus a into c square plus ca plus a square. So now the next step is, if you observe the power term a minus b into a square plus ab plus b square, what do you think? We have studied this already in expansions chapter, right? So this is an identity. A cube minus b cube equals a minus b into a square plus ab plus b square. So instead of the power we had, we're going to substitute the identity here. So instead of this term, we're going to substitute this term. So when you substitute in the previous step, you had a minus b into a square plus ab plus b square. So here in the place of this, you're going to substitute a cube minus b cube, as the identity says. So that is how we have got x power a cube minus b cube. Likewise, in the second term and the third term also, you're going to apply the identity, but in the place of a and b, here you have b and c as variable. Likewise, in the third term, you have c and a as variable. So now in the next step, if you have same base, you can add the exponents. So we have same base here, right? X, x, x. So if we have same base, we can add the exponents. So that is what I have done here. X to the power, I am going to add all these exponents. So now I am going to take this plus sign inside the bracket, likewise this plus sign inside the bracket. So we will get as x power a cube minus b cube plus b cube minus c cube plus c cube minus a cube. So now here you can cancel all the terms, since plus a cube and minus a cube will get cancelled, and minus b cube and plus b cube will get cancelled, and minus c cube plus c cube will get cancelled. So the leftover term will be 0. So you will get x power 0. And we already know anything power 0 equals 1. So the answer will be 1. So here we have taken the left hand side term and we have proved the right hand side term. The right hand side term in the given expression is 1. Hence we have proved the equation. That's it. Dear students, now let us quickly recall the basics of what we have seen in this class. So now explain indices. Very good. So indices says how many times that a number should be multiplied. Other name of indices is exponents or power. So the question is, identify the index for the given numbers. So for the given question, you have to identify the index. So what will be the index for 16 power 8? Yes, it is 8. So what will be the index for 5 power 3? Yes, it is 3. So the first question, the index is 8, and for the second question, the index is 3. So the next question is, rewrite the following numbers in exponential form with the given base. So for the given question, you have to write in exponential form. So the given question here is 1000. And they've asked you to write the exponential form with the base 10. So what will be the answer? Yes, you have to write 10 into 10 into 10. So that will become 1000, right? So the exponent is 10 power 3. So for the second question, 243, you have to write it in exponent form with the base 3. So how will you write? How many 3's you have to write? Yes, very good. 3 power 5 is 243. So next question is, solve 8 power 6 divides 8 power 5. So how will you solve the given question here? Yes, by using laws of exponents. So which law we can use it here? Very good. It is a power m divides a power n. So the law is a power m divides a power n. So that equal to a power m minus n. So when you substitute a, m and n value, you will get 8 power 6 minus 5, right? 6 minus 5 is 1. So 8 power 1, 8 power 1 will always be 8 only. Okay. So next question. You have to list any 3 laws of exponents. So far we've seen about 10 laws of exponents, right? So here I've asked you to list any 3 laws of exponent. Yes, a power m into a power n equals a power m plus n. A power m by a power n equals a power m minus n. And ab the whole power n equals a power n into b power n. The next question is distinguish between positive and negative indices. Give 2 examples for each. So we have seen what is positive indices and what is negative indices, right? So you have to distinguish between positive and negative indices here. Very good. Positive indices will have positive power and the negative indices will have negative power. So the examples are 2 power 3 and 3 power 2 for positive indices, and negative indices are 3 power minus 2 and 2 power minus 4. So here I have given you an assignment. Work out all these assignment sums on your classwork and submit it through GCR. The submission of GCR, the procedure is given below. So students who have not joined it, please do join immediately using the code given here. Submit your assignments on time. Thank you, students.